guys, my name is Zander
My name is Jeremy.
and today here I'm gonna be explaining the concept of the kinetic and potential energy with my peers Jeremy. I'm as well gonna be explaining the law of conservation and sort of stuff, you know, like that. And then the potential energy, the kinetic energy, the mechanical energy, I'm gonna be explaining that. I'm also gonna explain the concept of energy and everything that connects to it, okay? So without further ado, let's get into it. So I'm gonna be explaining, for the first thing that I'm gonna be explaining is the law of conservation. So the first thing that you see here is a person skating down, and you see on top of the hill, the person has the maximum amount of the potential energy that person could acquire, but on the bottom, the person has no potential energy. But if you see on this graph, like right now, you see the potential energy decreases when it goes down, but the kinetic energy increases, because kinetic energy just means speed. Kinetic energy means speed. That's the key word. And then the potential energy means how much energy is stored in a person, meaning that it's a potential energy. And that also explains why, kind of, you know, you've probably heard the law of conservation, which states that energy cannot be created or destroyed, but it's transformed from another form to another form. Why? Because you see here, this energy transformed from the potential energy into the kinetic energy. And that is how energy is transformed. From potential energy to kinetic energy. And yes, it is really that simple. You don't need to stress about it. Thank you. And now, since I've already explained about the law of conservation, you're gonna be watching the video that me and my peer made. It is a roller coaster that we made for the project, and it is awesome. Watch it. Okay, so overall, after watching that video, I would like to personally say that we could actually made it better if there were more time. If only there were more time. Because the time we don't have, and I want to show you guys that I put a lot of efforts into actually making the roller coaster into drawing, because I had to do it multiple times over and over again, and it was
75 years later.
And eventually I made it. Yeah. So yeah, it kind of look like this now. And there's also the extra additional information that you'll need later. But on the bottom, yeah, like that. Now I'll show you guys a time lapse where it involves the process of writing down all the formulas that are involved in a roller coaster. That includes the point A, point B, point C, and that's all. Yeah. If you guys are wondering where's point A, B, C, it's I've already written it all down on the picture that I drew on the last few seconds before. Yeah. And here are the formulas that you'll need to understand before we jump down into the calculations, guys. Okay, so now we're going to be calculating the point A first, and from here we can definitely know that the kinetic energy here is definitely 0, because the object is still on the top of the hill and it hasn't rolled down yet, so it's definitely 0. And then for the potential energy though, we can use the math times gravitational weight times 8, where if you input the numbers in their standard units, the answer will be 0.010388 joules. And the unit is joule, by the way. Yeah. Now for the second calculation, which is the point B itself, we can actually find the potential energy of point B, but unfortunately we do not know the current velocity of the object yet. So what we'll need to utilize is using the mechanical energy of point A equals mechanical energy of point B, and also letting you guys know that the formula of mechanical energy is potential energy plus kinetic energy. So here you can break those MEA equals to MEB to those PEA plus PEA equals PEB plus PB and blah blah. And then you can input the numbers there and then actually follow the mathematical process. And once you actually find a number, and if you're actually struggling to calculate this, you can use a calculator or anything that can help you doing the maths. But as long as you understand, it's gonna be easy. And then once you find the velocity, you can input the velocity into the KEB equals half mass times velocity squared, which is gonna be half times 0.002 times 2.4 squared, and the results will be 0.00576. and that's the kinetic energy for point B. Well, for point A, it still remains the same as 0.010388, but for the potential energy on point B, it is 0.004606. And now for the point C, it's not really that different. We can literally do the same thing except with different number, because here we can analyze that the point C's height is 0.25 meters, while the height on the point B is 0.235 meters. And that's basically the difference, and the results of the answer will also come out different. So yeah, if you input the numbers and then you calculate it, you'll get the answer as well. And that's basically how we calculate point A, B, and C. It's simple. Now for the second calculation, which is the point B itself, we can actually find the potential energy of point B, but unfortunately we do not know the current velocity of the object yet. So what we'll need to utilize is using the mechanical energy of point A equals mechanical energy of point B, and also letting you guys know that the formula of mechanical energy is potential energy plus kinetic energy. So here you can break those MEA equals to MEB to those PEA plus PEA equals PEB plus PEB and medallia, and then you can input the numbers there and then actually follow the mathematical process. And once you actually find a number, and if you're actually struggling to calculate this, you can use a calculator or anything that can help you doing the maths, but as long as you understand, it's gonna be easy. And then once you find the velocity, you can input the velocity into the KEB equals half mass times velocity square, which is gonna be half times 0.002 times 2.4 squared, and the results will be 0.00576, and that's the kinetic energy for point B. Well, for point A, it still remains the same as 0.010388, but for the potential